Hi, this is the second video on the new rules introduced in Chapter 7. In the previous video, we looked at the two instantiations, universal instantiation and existential instantiation. Those are rules that are intended to remove a quantifier. Now let's look at the two generalizations. There's universal generalization and there is existential generalization, and these are rules that introduce quantifiers. Now, universal generalization is basically the rule that if you have an expression such as this one, fx, you can go from it to for all x, fx. So you can introduce the quantifier. And if you think about it, it makes sense because you know that x means really any individual within the range covered by that particular domain of discourse. So if you're talking about a certain particular set of things, to say x within that set of things is to say any individual in that set. But if any individuals have property f, that's a kind of a different way to simply say that all individuals have characteristic f. And so when you have an expression like this, an expression that contains a variable and no quantifiers, you can go from it to for all x, f of x. You can also generalize from a constant. You can have a situation where individual A has the quality f, and you can validly infer that everything has that quality. But there is an important restriction. You cannot simply say that because one individual has the characteristic, then all do. The restriction is that if you generalize from a constant, as I stressed down here, the constant must be new. It must not have appeared in the premises, and it must not have been introduced through existential instantiation. So it is a constant that has to be completely unspecific. If you think about it, this makes sense. Think of demonstrations in geometry, for example. You know, the triangles have all sorts of properties that have been studied and discussed. And when you give a proof that triangles have a certain characteristic, for example, that the sum of the internal angles of a triangle adds up to 180 degrees, when a mathematician tries to prove that, he or she will choose a completely unspecific, nondescript triangle, a triangle that has nothing special about it. You know, they wouldn't want to choose a triangle that has a right angle or that has sides of equal length or anything of that sort. They would simply want to choose a run-of-the-mill triangle, a John Doe of triangles. And if this individual that has nothing special, nothing remarkable, that is chosen completely at random, exemplifies the property, then you can conclude validly that all individuals in that set have that property, just as from showing a certain characteristic in a completely nondescript triangle, you have actually proved that all triangles have that characteristic. So this is universal generalization, so keep in mind the restriction. And finally, existential generalization. This is probably the easiest one, the one that makes the most sense. Suppose that an individual has a certain quality. So individual A has property f, or let's use a concrete example. Barack Obama is taller than 6 feet, okay, which you can express as TB. from this, you can always validly go to there is something that is taller than 6 feet, right? If you know that the one thing, one individual, one person in this case, is taller than 6 feet, then obviously it follows that something is taller than 6 feet. And so that's how you introduce the quantifier. Okay, obviously this works not just for simple expressions, but also for more complex ones. You know, if you know that a certain individual has, call that individual C, has characteristic T and P. So you know the C is both T and P in terms of characteristics. Then you know that there's something such that that thing has characteristic T and characteristic P. Okay, so in this case, the generalization obviously involves the whole formula. You go from the constants or names of individuals to the variables. Okay, so this rounds up our discussion of the new rules of chapter 7, and in the next video I'll give an example of a proof that uses these rules. Thank you.